how do we debug, and how do we resolve. Okay, so that is first thing. The second thing is, related to specifics for tool related aspects. That I think is a, certain things that we have to talk specifics to the tool ICC and this one, which I don't think we can cover in this particular context, but we will touch base because this is more to do with an interview for this, where I will try to look at if some possible, uh, you know, universe related commands. Yeah. So, but you don't have to essentially worry if you have not done that, right? But specifically what techniques, what you have to use, that you will have to map to the relevant. If you're it's ICC, we can talk about ICC. If it's universe, you can talk about that. If it is appraiser, then you work with that. Or if it is like, uh, uh, some other tool, right? So IBM, chip bench or something like that. So we can map it to any of them. So specifically, I'm not going to touch more towards the tool, but talk about, rest of it. Flow related and issues with the physical design, how do you resolve them, right? So that way it's going to be a long discussion, but we will break that down and it'll be like interactive session. I'll ask questions, you'll have to answer, you can ask questions. Like how? So we'll first start with your questions. What is that typically you get in a PD interview, right? So when you go, what is the first few questions that they ask? Let's try and answer them. Anything, each one.
So we'll start from floorplan itself. Right?
You can speak little louder so that everybody.
Yeah.
There also.
Recently, means one of my friend showed me that techniques, but couldn't possible to get totally.
What was the question?
Question was, side rows were different.
Ah.
It's different sizes.
Ah.
Size one is 0.038 micron, and one is 0.04 micron, and one is 0.0376 microns. Like the different size, different side rows will be there. So over the macros, we can't place the macros exactly. Means over the side rows. Because different size will be there. So how to make that possible? So see, because that one, that AMD only, MI 400 is there, right? So that 4 nanometer technology. So that one was facing.
You mean the cell site rows itself is different? That means circuits. Okay.
Different. See, over on the top, you can't place the macros exactly right.
Not about macros, right? First is about the standard cells.
Means they're facing standard cells, okay. But over the different size of site rows, placing the macros facing difficulties.
I didn't understand. The site row is okay. See, if you understand site row, right? Site row is about the standard cell height. Okay. Yeah. You're saying the standard cell site row or circuit row, see, there are 2-3 things. I hope you are not confused, right? So one is circuit row means, whatever standard cell is there, that's the height. You're saying there are different heights.
Yes.
Okay, different standard cells.
Yes.
Okay, that is not possible. Okay, within a certain, that's not allowed. See, it is possible to design. Okay, but it's not allowed because the current manufacturing rules, okay, does not permit, because you will have a lot of yield losses. Okay, if you have to have different, you can have single height, double height, triple height cells. Okay, within the same framework. But
means single side row or double side row?
Double side row or triple side. That means the side row will be same. The cell design has to be like that. So if you use that particular technology, for example, like this pad.
0.0. Next to 0.1 only it will come. Next side row.
That's the side row because that's the height. See, so there are manufacturing grids are different. So grids and this one are two different things. Okay, so we have to have understanding about manufacturing grid, routing grid, site row. These are different
but
aspects.
Starting.
Let's understand. Okay, if you have to deal with different site rows, that means it's completely different library. You cannot mix everything in a single shot.
Yes.
Okay, you'll have to create separate domain, like separate block. For that, you'll have to create, for that particular block, you can have site row. But in one site row, one block, it has to have a unified site row only. Single light cell, double light cell, triple light cell only can be used.
Okay.
But the problem is when this get manufactured as a chip, right? You have to understand that the machine has to actually go through that, same layer. Okay, if there are actually disturbance like that, it will be yield losses, especially lower node technologies. We have already said double, when we are actually talking about double pattern, triple pattern, even to create, that certain thread, it is actually, during etching, right? It is actually spreading because chemical vaporization. So you'll have to give some time for it to cool. That's when the second pattern can be overlaid on. The idea of double patterning, triple patterning is first pattern is laid, then after certain cool period only second pattern has to be laid. Then only you will be able to create that minute, pitch. Otherwise, what will happen is in a single layer, if you are trying to merge, no, it will create gases, shorts, etc. That is the idea of double pattern, triple. And if you have so many grids coming in, then there's a real problem. See, this could be a question, tricky question for you to actually ask, because you should not try and say, okay, that may be reality. First thing you should actually try and answer this question. But if it's a real problem, we will discuss. Then you'll have to create separate domain. Okay, why that is done, I would not recommend. As an architect, I would not recommend, using this different stuff, because that's where the FinFETs, everything has actually come to reduce it, because it's going to really impact different mixture of standard cells, their performance, their characterization, everything will be real problematic. Then you have to use a lot of modeling to actually deal with it. So first thing your answer should be is multiple, unless it's a double site row or triple site row, you cannot have that done in a single block. But if you have actually site rows, which means, circuit row height, standard cell height, which are actually different, more than, like 1.5 or 1.25 or something, not multiplier, then you'll have to create a separate voltage island so that the cells can actually sit. Because otherwise, what will happen? Because on the site row is when you are creating your VDD VSS. Then if you have 1.38, then another 0.5 will go like this and all. No, it won't be able to place. It will create, it will be a mess. You cannot do it. Okay. So you'll have to completely create a ring around that, isolate it, so that, the VDD for continuity issue, you can actually connect it, but it has to be separately. That itself, even though it's a single voltage, you'll have to create like domains and create separate block. That will be a separate partition which will be done, but manufacturing and yield losses can happen. So this should be your answer. That's first of all, not allowed, not recommended. Multiple site rows cannot be done in a single block, but as a single chip, if there is a requirement like that, basically that this is a high performance, okay, certain things, then you'll have to create a separate voltage
domain for
separate domain for that.
for each
Yeah.
sector.
Yeah, the voltage supply can be the same, but it has to be separate block, okay, and with a power ring. Okay, because the mesh pitch, everything will change if
Yes,
your whole stuff is actually going.
Yes.
So that should be a clear-cut answer that it is not recommended, and I don't think any of our chips will allow that. Okay, that should be the answer. And so, I mean, you can clearly say like that. Okay, that's so. Okay, any other question?
Next one about the design. It is the same now.
Generally, yes. Okay. Now he was talking about macro placement problem. Okay. So first thing we said was standard cell. Here, if it's a single site, so there can't be a macro placement problem because macros will sit only in that domain. So what exactly, I don't understand what is the problem really this guy is facing. Okay. Because if it is microgrid or certain things, we need to actually understand. Okay, maybe you can connect and clearly In the evening, we can
Yeah.
discuss that. But for all the interview purpose, you can assume that this is the. What is the other question? Please.
I can add some more in this, sir.
Yes, Satish?
Yeah, actually, in that question, I thought that one more tricky actually is asking of the different height of site row. But what is the main thing is it depends on the, as you told, multi-height cells. It's the in the proper way of answering it is depending on the multi-height cells, because the standard cell height will be constant, width will be varied. I mean, width will be constant, height will be varied. So I think he is asking of multi-height cells placement.
Multi-height, I have already answered. No, it can be
Yeah,
one
yeah, that is a
single
thing.
height or double height.
Yes, yes, that
Okay,
is a
your width can actually be
constant.
multiples of uh,
W-
routing
Width will be,
grids.
yeah,
Okay.
Can vary, height can't
Height has to be,
It's-
yeah, but you can have double height cell or triple height cell. There also, when you have double height cell, you should understand that there is the VDD in a double height cell, right? Because the top and bottom will be VDD, in between you will have ground. So you'll have to have 3 layers connectivity. In a triple height, it will be like, two VSS, two VDD. You have to understand that these are in between connection, power connections, etc. will come. So generally, double height cell you can expect, but there could be some specific cells which are of triple height also possible. Okay. And especially when you are using, there's also this, you know, uh, what you call a flop register array. Now you have something like this, right? What is that? Register bank. Okay, so a tall set of stuff where you will have only that is created to actually reduce the, but it will have only one clock pin. Internally, it will be connected like that. So wherever you are using register banks are actually used in a design to reduce the area. Okay, but register banks placement again will have like multiple, it can have like 10, 12 banks, means, it will be like 10, 12 rows consuming. Okay, the tool automatically places those things also. You don't have to necessarily floor plan, but you'll have to be aware that that can cause congestion, wherever it is being done properly. And in the timing, once you are looking at internally, because you'll only connect to the one clock pin, but internally it could have different problems. Okay, that particular flop will be, you cannot just queue this. If you just push this clock, you will automatically see that, okay, one register is failing old, the other register is
Setup.
failing setup, right? Then you have to debank it, or you will have to look at, fixing the timing problems differently. Okay, so or internally, so these things you have to be very careful about using register banks, because they are all part of the designs. Okay, so register banks are there, so once you are actually making sure, if they ask the questions about register bank, you can say like that. Okay, so because what will happen is the clock is coming means clock power reduces, right? You'll, with one particular clock getting cell, you can entirely shut off the entire bank. So clock banks or register banks also you have to use for that particular module. So these are all built up. Okay, internally the tool has intelligence and actually the way it need to be done. But sometimes when you get into timing problems, how to deal with it. We'll talk about that in a certain case. So start talking about floor plan. Okay.
One more thing in floor
Yeah.
plan only. As I asked so many people say, but not experienced like as you.
No problem.
Most of the people's preferring manual macro placing
Yeah,
compared to automation.
correct.
Why?
Okay, so
Whatever I did automation only, but most of the means master part of the project I did less macros something, but some of the project having 56, 86 macros were.
yeah, exactly. See, I mean, automation is only the last resort. You should not use automation for your macro placement. All my macro placement of floor planning techniques will be manual driven mostly. Okay, this is how we have to do. Why? Because in an automation, right, the tool would place the cell, it treats like any other cell, macro. Where, okay, so it will place, okay, where it is, because when you're looking at a tool point of view, what is its goal? It works on algorithm about two things. First is you have to understand how the algorithm works. So first is how do I reduce the route length? If you talk about Monte Carlo, for example, it'll you have a block of let's say 2 by 2. Okay, 2 by 2 is the block. How it will do is okay, I have some 100 cells to place in a 2 by 2 square. So it will first divide the 2 by 2 into, let's say in the middle, first half. So it is 1 by 2, 1 by 2. So it will take the cell, 2 cells, it will first push the cells into this particular placement and it will say, what is the route length? If I move this cell from this 1 by 2 matrix to the other 1 by 2 matrix, will my overall net length reduce or it will increase? Okay, so this is the decision making. So one, it's actually parted. If you have seen that there are 20 steps, 30 steps, if you have looked at a log file, right? Placement, global placement one, okay, step one, step two. The way it is doing is it is breaking down this 1 by 2, 1 by 2. Then after that, it will go in the horizontal, first vertical, next horizontal, next again vertical. So now the 1 by 2 boxes will be broken into 4 boxes. Then 4 becomes 8 boxes. 8 becomes 16 boxes. Like that until you get into the global box. So this is what is global route where 7 track.
Particular area.
Yes, only particular. So this is how the tuning happens. The first criteria for any particular placement is by placing the cell, I am reducing the net length. So net length is your first criteria. Okay. First criteria is net length. Basically, it is trying to use your cells as it is. Okay, where it is doing course placement. Course placement, it is not optimizing, it is not sizing, it is not doing any damn thing. It is trying to place yourselves as it is, but with the context of route length. Okay, now with the context of route length, it will try to place. Now, if you are doing timing driven placement, then it will start analyzing that as a criteria first. Okay, first for generic case, I will tell you. So route net length. So net length it is placing. Next it will check, okay, I have placed this. Whether it is violating, the next check for that is my net length is fine. Okay. Whether my density is okay in this area or here. You have put density like 80%. By default, the tool has maximum density in any particular cases by default 95%. So it's in that particular cell domain, like 7 cross cell 7, okay, matrix. If there is more than 95%, then it's a violation there. It will try to de-violate. Okay, if you have put density screens, for example, 50% only criteria, then it is going to check those particular criteria. A 50% density, I'm not supposed to place like this. Okay. Now, the next part about it is whether it will enable the timing after that. Just enable the timing, update timing. So once the update timing happens, it will check what is it happening. Okay, because now when it is checking, it will use Manhattan distance. It won't use the route, right? Manhattan means exactly between this to this, how much is my rectangular distance? That's the Manhattan distance. Your route can go all around the place and route it. That is a different thing. What is the shortest routable distance? Because it cannot have a diagonal straight line, right? It has to have horizontal and vertical. That is called Manhattan. So in that, what is my shortest distance? It will enable the timing and check. Hey, this guy is violating, so there is not a possible location. Then it will go and alter. That is your global route phase 2.
Okay, second phase.
So you will see 3 or 4 phases happening. In each phase, 20 steps. What the 20 steps I told you, right? How it is breaking down in a Monte Carlo technique. So there are like this, so many, you have quadratic placement, you have so many algorithms. Okay, I don't want to get into algorithm discussion, but I'm telling you, okay, because I've looked at about 4, 5 algorithms, seedling, so many things are there. Okay, heating, stuff like that. So in this case, this is the way it is looking at it. And then, where it will do is, okay, now I have to place it like that. So this is all about course placement. Okay, where it will try and optimize and look at that, then comes, okay, I've placed it wherever possible. Now I have to actually go and do buffering, or we will talk about those steps. But in the importance of course placement is like this: net length, that's the first priority. Second is after net length to be able to match your criteria of your tents. In case you have put a upfront a criteria of, for example, magnet placement, then the first thing it will try to do is place all the cells to the closer to the pins, because that's your first criteria. It will give that the highest priority. If you have put any of that constraint, or if you have put a move bound, or if you have created a cluster, it will try to place those cells as a first priority like that.
Yes.
Then it will try and place. Then it will enable and check congestion. I have routed whether it is actually done. Oh, now I have to move this cell. Now this whole thing changes as you start giving it norms. Okay, timing effort high means what will happen? At which step that gets priority? You have to think about. We'll discuss about this. Okay, because let's finish the floor plan questions. But I have given you a general frame view of how a placement stuff happens. Okay. So any questions on the floor plan?
I think macros, so you can do all the according to rules, like whatever.
Yeah, sorry. That was the context of the question, right? So when we talk about macros placement, so it will also look at, that also comes in that it doesn't look at any specific thing for macro as such. It will go by general rule like this and try and place, and whatever is the requirement it will do. So, but macros are more than that. Okay, so more rules than that, which if you add to that particular algorithm, it will complicate. So macro based rules are not added to your generic algorithm. That is what is the next future of AI induced physical design automation, which is going to happen. So what we have to do is macro placement. When you are looking at it, you have to look at it from which are your modules, because you want to drive. Otherwise, it will just go by the technique. Where is my shortest net? Where is my congestion? It doesn't care whether your module is split, whether your module is sitting, because it has only 2-3 criteria. I have to meet my congestion. I have to do this. But there are other problems which will come later with regard to clock skew, how you have to manage your domain, etc. So this is why you have to. It will not converge. One is it will not converge. Second is your design will not be in your control. You won't be able to say when you are closing the design. You will say tool is not doing, tool is not doing. This is the stuff. What can I do? Why are you there? Right? This is what happens. You have to have your design in your control. I never trust the tool. That's my problem. There's a other problem with that if you don't trust anything that it happens. But that's the mindset, right? So when you're doing macro placement, general philosophy is you have to understand what is your block supposed to do? Where's your architecture? Where are your inputs? Where are your outputs? That means where are your input ports? Where are your output ports? Okay. How is this whole in terms of actual design? How is this whole module talking? Basically, module A is supposed to talk to module B, supposed to talk to module C, supposed to talk to module D. So you have to actually understand this particular flow. Okay. So whether Mealy machine or more machine, how this whole thing is flowing. And your floor plan should be aligned towards that. You may not be exactly matched. Hey, this is there, I have to place it next. It's not possible. You cannot place macros every Tom, Dick, and Harry, because across the macros, when it is routing crisscross, shots, DRCs will come. So because around a macro, you have to do so many care abouts. For a standard cell, there is no such thing. Here you'll have to actually add, because there are 100 pins coming out of macros. Okay, and each pin, because you cannot move the pin as it's required, right? In a cell, you have flexibility, you can move. Macro, you don't have that flexibility. One macro movement just for this pin is critical. Then the tool will get confused. Okay, this guy is a problem. So you will have to actually design. That's why macro placement is so crucial. Because if macro cannot meet timing, you have control to break the macro into two pieces.
Macro also.
Yes, memories also. We can choose the type of memory because memories have actually multiple version, floor plan, because you have to understand library has 3-4 different varieties. High density library means what?
Means it will occupy more the area.
Less area.
Sorry.
High density means
Less
it is
area.
an area optimized cell.
Reverse.
You understand? High density means highly packed.
Okay.
Density is high, it is packed.
Okay, okay. We thought
No.
much internal density.
This is why the terms are so important. Density, high density means what? It's
It's
highly
packed.
tight. So dense design means a very tight design, right?
Then it will
The low density means it's a loose design. High density cells means it's a highly packed, area efficient. That is the idea. High density will always have timing problems, right? Means the access time will be more, etc. So it will not be timing optimized, but it is used for area optimized. Okay, you have to understand these things. So when you have a memories can be built, if you are look at XRAM, if you are looking at a square RAM, right? The problem with the square RAM, it will be area tight, but you look at that, the bit is in the bottom, the pins are at the top, so the access time will be longer for some particular, paths. You need a very timing tight means it will be thin and narrow like this longish memory. It is called a register, right? High density memory, high speed memories, or high speed cells, high density cells, low power cells. You have so many variants. You have to understand what each one, what is the trade-off you are doing with that. Okay. If somebody says I'm using, you have to ask a question. I have a problem with my design, it's not meeting timing. So in the interview, if they are asking, okay, so what are the options? You can ask, let us say you are doing early design, it's not meeting. Are we using high density cells? What kind of libraries are we using? Did we exhaust the options in terms of library? Do we have a high speed library? That is one of the options. Why are we not using? They may say, so that means you understand that that there's an option like that. Until you won't be able to utilize. No, somebody, because today everyone, they give you keep doing, okay, run the tool is not closing. That's not the way to going. Should know first what is there in my hand. So similarly, memory, if it is there, 64, 4K, 4048 into some 64-bit memory, that is a bulk memory. This guy is not closing time. Okay. That means, this is a bulk memory. Can we break this memory into two? You can break it into 2040. The problem with breaking that is you have to add that many registers also for the outputs. You are breaking, you can create two libraries. So you'll add more area to that. But if it's an important thing, timing has to meet for me performance, whether it can meet or not meet, or do I have other option? Okay, so these have to be tried. You cannot use thin and narrow memory like this. What will happen if you have put that one cell will sit there, one cell will sit there, eventually the timing will have a problem. The module will get split, it will be very difficult. You will see access time is less. But eventually for your timing closure and congestion for your floor planning, I've seen somebody adding memories, that memory is going outside the plan. Okay. Then you have to rechange. This is called muxing. Yeah, memory muxing, you have 3-4 options. They will give like thin and narrow, 4x1, 2x2, like that. You can look at which muxing. You should ask what are the muxing options available, which memory, because mostly front end would have chosen. But whether that fits my criteria, because then you'll have to give that feedback. This is not meeting timing in physical design. I cannot floor plan. Then once you give that feedback, then they will go and change that.
Changing, and again they will give
Yeah.
one more.
Because their objective is initially to try and use minimum area, because the cost of any particular fabric has three things, right? Your area also is very expensive, silicon area, if they are doing multiple stuff. Okay, so that's a problem. Power consumption is also expensive, so they may have used low power. Okay, low power, they may say low power, but whether it is low leakage, low power has three connotations. It's leakage or it's dynamic, you have to understand. Hello? Morning, morning. Ah, ಹೇಳಿ ಸಚಿನ್. ಫಾರ್ಮಸಿಯಾ? ಸರಿ. ஃபார்மசினா என்ன வேணும் உங்களுக்கு அதுல? ஃபார்மசி அது ஃபார்மேட் கொஞ்சம் அனுப்புங்க எனக்கு. ஓகே. ஆமா ஆமா, என்ன வேணும்னு அனுப்புங்க, பண்ணி தரோம். ஓகே. வாட்ஸ்அப் நம்பர் தான். அனுப்புங்க. So, so it's an important thing, okay, to understand that how you treat a memory macro. When you have these options, the tool does not understand. No, tool is a dumb thing.
Whatever we are telling that.
Yeah. So first, you have to understand your data flow diagram. You have to understand even before data architecture. What is this block supposed to do? Where are my IOs? How is this guy connecting to? These should be even before you start anything. Because only at the start they will answer these questions. Not when you are actually at the routing stage, you have a problem, they will say, what the heck were you doing? All this, why you are go get lost, you close the timing, you don't know. This is how it will happen. Only at the start, you have that window to ask these questions. So you should exhaust those questions then and there. You understand? So what are the library options? Can we do this? Can we do this? Can we do this? Okay, is this the only library? Are there high speed? No, that's not an option. You are supposed to only use this. That means you are ruling out. It is his responsibility. Then it becomes his. You never told me this now. I asked you this question. So you have to understand that those options exist. And this is supposed to be done. If my memory is not meeting, you can always go and suggest back at the placement. This is the problem. Okay, let's say. So that's what is expected. Okay, right? At an engineer level, you may not know, right? You're new to certain thing, but this is what we have to do. Why floor plan has to be done manually is because the memories, from an architecture point of view, first the placement. Okay, then basically, and once you place the memory, they become a critical criteria, initial point for the standard cells to place. Because they will start, then it will look at, okay, this guy's route length, memory is placed, you have fixed it. That's why you have to fix it. You cannot keep it like unfixed, floating. Then you are not doing the right thing, right? Because around memory, when you are placing, you have to take care of the memory to memory rules. Whatever spacing, you have to route it properly. Then if the blockages have to align, okay, whether the memory has to face each other or they should be against each other. These are things that you can take care. You have to spend that enough time on just memory placement only. It's okay to take 2 days. And just do course placement. The idea of placing memory and placement, you should not go for complete placement initially. You should just do course placement, module placement to see whether the modules are sitting properly. It's expected as you have actually discussed in the design. If that is not coming out right, there's a problem. Hello? சரி பிரதீப், நான் பார்த்துக்கிறேன். சரி, ஓகே. சரி, ஓகே. சரி, ஓகே. Okay. So the key part to understand is macro placement has to try and match your data flow diagrams, and you spend that time to make sure other than whether which way to align, what is the orientation to use, right? Orientation and you know mm, horizontal, vertical, all these you already are aware to an extent, right? Basically you are trying to actually try to make the pins place the core area, core direction, so that the standard cell can talk to them. What is the we will talk a little bit, because if I spend the time on macro only, I may need one full day to explain how you can compute. I'll give you a simple example. If there are actually, let's say 16 macros in one particular module, and they are supposed to connect to a logic, and you have to compute the channel area, because these 16 macros are to be placed. You cannot actually play, abut all the 16 macros together, right? You will place it in certain rows, okay, or maybe certain 4, 5 together. First thing, whether how many macros can be abutted without a logic space, you have to understand that a macro pin can drive maybe 100 micron or 200 micron. Okay, beyond that, the load capacitance on that pin will be higher. Then what happens is your access time will become more. So it at least needs one buffer. So if your each macro width is, let's say 80 micron, then 80 micron plus some routing, if you are adjusting 10 micron gap I'm leaving, so 90 micron. About, if your maximum drive distance is about 200 or 300 micron, you cannot have more than 3 macros side by side of each other, because after that you have to leave space for logic. Okay, this should be very clear for you, that how many macros can I abut before I actually do the logic, because one macro the pins are facing. After that there are two macros, means 100, 100, 200. So this pin can then travel 200 before it reaches the first buffer. You understand? I will show you diagrammatically also if required. So that's the first criteria, that I may not be able to abut 8 macros together, because then 800 micron means its load will increase, cap load will increase, its setup time, clock to queue delay, everything. So maybe one or two memories, or maybe 3 memories, depending on what is the load that it can drive. This sometimes, if you're not able to get the data, you can actually try one experiment. Okay, put 4, it's not possible, try 2. But generally, as a thumb rule, don't try to abut more than 3 macros together. That could be your initial experiment, and beyond that, you can actually.
So if macro length is less, if macro length is less.
Yeah, macro length is less. Accordingly, you can add more macros. Macro width. If you are actually looking at height, right, then your cells, see which way is your cells facing. Cells are facing bottom, or cells are facing on the right side or left side. Okay, sideways or bottom and top. Then it becomes like, okay, you have placed memories vertically over there. That longest pin has to travel the length of the macro.
Too long.
Okay, the length of the macro now itself is what? Let's say length of the macro is 200. Then the 200 itself is a long distance for you, right? So in between you may have to, so that's the maximum. Then after that you have to give space for the standard cell.
Yeah.
You understand? So they should be very clear when you are approaching how you actually alter your floor plan is. What is the maximum distance, and which is the worst case pin for my timing, for my routing, has to be very clear. Now, if I have, as I said, right, 8 macros, right? How many channels I need to give? So let us say I pair, just for a simple example, I say a pair of 2 to 4 pairs are there. So 4 pairs means, let's say each memory has 100 pins. Okay, 100 into 8 macros, 800 pins I have.
Both input output.
Both input and output. But you have to know that this may be part of the same module. Inputs may have common connection. That means the same one net may be connecting to the same 4 or 8 of the D pins. Output you cannot have multi-driven. You can have one driver actually connecting to same different D pins. So when you're looking at the fly lines, if all the D pins are connected, that means one net only for that. You should not multiply by 8 pins. It's like one net only. That's the net for which you have to compute. So how many D pins, how many control pins, these are all inputs to your memories, which are actually coming. So if they have to be, that may be unique, or that can be different also. So you have to compute. That's where you will have to look at the fly line of the matrix. If all the fly lines are connected, means this pin is connected everywhere. That means that's when you will have to compute it as one net. Otherwise, you should not. You should compute it as multiple nets, as many nets are possible. You understood? So then you will have to outputs will always be different. If there are like 50 output pins, 50 input pins are there, means 50 into 8, 400 nets will be there.
Into 8.
Yeah, I am talking about 8 macros, right? So 400 nets has to be routed. And this particular route can happen that the cell can be there positioned, or if the cell is at the bottom. Okay, we are talking about channel where the route has to happen and then come and connect to the cell, which is actually sitting at the bottom, means that's the 400 nets plus 50 nets, which may be common across. So total of 450 nets has to be routed in the channel. Not like 100 into 8, 800. No. So 450 nets. And where it is going to be maximum, wherever it is actually exiting the full macro set. Okay, because for the top there may be 20 nets only, but as it comes towards the bottom where it is connecting, because more pin nets are actually entering. So that's the peak where it is going to happen. So what it will happen is now 450 nets, and let us say you are talking about vertical layers. How many vertical layers you have? Let's say it's a 8 layer block, 8 layer technology. Then you may have 3 vertical layers or 4 vertical layers. 4 horizontal, 4 vertical, but M2 you should not use for channel maximum routing, but in case you want to consider it, also consider it. So let's say 3 vertical layers are there. So 450 divided by 3, that is like 150.
150 each.
150 can be routed in each metal layer. If it is 100% utilized. So you have to look at a utilized, but if all the 150 nets are actually routed next to each other, crossed up.
Obvious.
Right? So you have to actually put like 50% utilization or 60%, because you have to factor these things. That means in the metal, I'm going to route, even though I can route 150 nets, because if it's long nets, then there's a problem. Short nets, it's okay. So long nets means 60% utilization. Let us say I take 60% utilization. Then if I say 60% of this 70, 150, then it becomes 100. Sorry. So divided by 0.6, 150 divided by 0.6 will become 225. Something like that. Okay, 225, 230. That is the total net length is required. Now for each pitch, the pitch for any net in metal 3 or metal 4, you have to multiply accordingly. So let's say the pitch is about 0.5 micron. So 0.5 into 230 nets. So that should be your total channel distance. If your pitch is maximum in M6 or something, you have to take that into account and accordingly calculate. So, and this is the actual, whatever 230 into 0.6 will become, sorry, 0.5 will become 130 micron. That is your channel required. So these are the ways you have to compute. You understand? Yeah, let's talk about some floor plan questions. What all typically you get? I'll also, because I can ask so many questions. No, better. Yeah, Suryavel, any questions you are faced in
Uh,
floor plan?
Sir,
uh, yeah,
sir,
hi there.
still I know. Yeah.
Yeah, one at a time. Let Suryavel, then Satish, you can also ask. Yeah, go ahead. Suryavel.
Yeah. Um, while handling, several macros, but belonging different groups or sizes, and like let's say 512 k a certain number of RAMs or macros. Similarly, 256 k size of RAMs and lower. So there are situations where a design may have, I mean, various such macro groups, and according to the given core area utilization, there is a possibility of notches uh, at the end of the macro placement. Am I right?
You are not very clear, Suryavel, with your question. So what is that?
No. No. Can you please come again?
You are not very clear, Suryavel, with your question. Can you repeat
Like,
what
okay,
exactly you are
okay.
trying to say?
Yeah. The situations of notches,
Ah.
yeah. That too in low power designs, as the number of
Ah.
macros are very, highly significant. So how do we handle? Uh, can you please share?
How do we handle high macro count?
Yeah, the routings, I mean placement and then routings. Maybe post space setup fixes will have as a significant amount of work in case of notch based floor plans.
Yeah, let's
So how
talk
can
about
we avoid?
notch-based floor plans, right? So your question is, if it's rectilinear and there are notches, how do
Yeah.
we place the macros in those cases? Is that the question?
Yes.
Okay, let me answer. So so let me actually try to draw here once again.
Can you please share the picture?
Yeah. I'll try to do something. Let me know if my screen is visible, okay?
Yeah.
So let us say this is your block. Okay. And you have notches, right? 1 minute.
Yeah.
1 second. I'll build some rectilinear. Just creating things like that. Okay.
Yeah.
Let us say you are a block. Just for the. Is it clear? So you can understand the outer layers as. Okay, just putting. Okay, some example. You have notches like this here and here. How are we going to deal with this? Okay.
Yes.
You should never allow standard cells to be positioned. If you have tiny notches, it's okay to cover up with blockages, or if you have macro, pack this macro in this notch. Macros you can place. You place the macro. Such that pins are positioned at the out. Standard cell should try and occupy. Place the macro here. Because this is a hard block. No. If you are allowing standard cell to come, the route will go like this and come inside. That means the timing loops will be long. So try and place the macro into this. Okay. Only allowing the pins to have the access because this is the area, dummy area given. So you try to utilize these particular notches with macro pins. Better to avoid standard. Yeah. Let me give you another example. let me say I have.
Is it no? Can it be inside a single core itself? Shall we think of as a notch
Sorry.
inside the left side? No, the left hand side we have got a square block. Let's
Yeah.
imagine it's a core. So shall we think of how do we or what are the possibilities that we can get notches out of macro placements? The macros are of different sizes.
Correct. Macros are of different sizes, and how do we actually place those macros? See, first of all, you cannot place any macro that will fit this size.
Yes.
So irrespective of macro, you have to actually have a data flow diagram. That's the most crucial thing. You have to look at your hierarchical browser. Irrespective of your tool, open the hierarchical browser. Let me say this is one hierarchy which is supposed to place over here. Okay. So I'll give you that particular floor plan stuff also. I'll tell you how to look at that. But let us say this is supposed to be one module which is supposed to place here. Let's call a module A, and module B is supposed to place here in module B. So if there's a memory in the module A, then that particular module A memory you can try and place here.
In case if module A having macros.
Having macros. Then only you will try and position.
If
You
not,
cannot add module B's macros over here. That will be a problem.
yeah, timing problem will come.
You are creating module
Yes.
split. That's not
Because-
acceptable. Okay. So I've given another example like this, L shape. How will you place your macros? Which is the good option to place your macros?
Because both side.
Okay, so this is a general, I mean, this is why I asked this question, right? So Sridhar says place the macro in this particular common point.
Macros will communicate both side.
Yeah. That depends on the number of macros and the IO positions.
Yeah,
that-
see,
let's say vertically.
irrespective, let me tell you, okay, you will not place because macros will only talk to whatever is the stuff, right? It will talk to one particular module or certain things. You should never place a macro in something common point, just like you are trying to isolate. You will try and place memory. This is the logic which has to actually communicate.
If you block
Yeah,
the
it should
If
be
you
common.
block this, then there's no route possible.
Yes.
No cell position possible. If it has to buffer, what it will do?
So we should let the standard
So
cells.
if you are putting, that's when you are putting off your interviewer. Okay, you will say that it's not dealt with. Should
Yeah.
never, it becomes, it's like intuitively you think that, hey, this is a common guy, place the macros. No. Common area. Why we are actually saying, where will you place the macro? Memory, will you ever place in the center? That is the wrong. That should be the
Oh.
least. Unless it is really required, you will not place the memories at the center. Similarly, see, this is basically because logic can move. Your macro should not move. Logic can actually distribute based on congestion. If you are putting this, what will the tool do? It has no option to do anything.
So then we can split into.
You have to try and,
Here
yeah, for whatever it is, you have to try and use the memories to this edge. You cannot even place the memories like this in between, because then what happens is across the stuff, you should try and use these particular ends as much as possible for placing the memory macros.
Yes.
So that the logic can move smoothly to try and meet your timing. That is should be your initial thought process of your floor plan.
Yeah.
You understand? Right? So whenever you are getting notches, see, the whole idea is like that. Allow the logic to be able to access every corner, so that this is not going. Okay. But you should not place the logic in one corner, which is blocking it from accessing other points. No. Only the standard cells can flow. Hello?
Hello.
One
Hello?
second. Yes.
Yeah.
Yeah, tell me. बहुत हो रही बोलिए. नहीं, थैंक यू. मुझे अभी नहीं चाहिए. मुझे रोज मिल रहा है कॉल. मैं जब चाहिए मैं बात करूंगा. ऑलरेडी बात कर रहा है. Thank you. नहीं चाहिए यार. Thank you. Okay. So does it answer? You want any more examples of notch?
Yeah, I have. Yeah, I need one
You
more
can share your
clarification.
screen. Ask your question. No problem.
Hello.
Yes.
Hello.
Yes, go ahead. Go ahead. Ask Suryavalli.
Yeah. Sorry, here is a signal issue. So at times I face some voice break. So what are the critical stages where we need to look back and reiterate our floor plans, maybe from post CTS or later stages? So what shall be the right critical scenario that leads floor plan reiteration and without leaving any other choice?
Okay, let me answer that question. What are the scenarios which will need reflow planning? Is that the question?
Yes.
Okay. So up to what stage? See, let us say, good question. So let us say your placement condition is good. Okay. Your power domains are all fine. At placement, you are thinking that your floor plan is good. The maximum stage that you should look at is up to CTS construction. Beyond that, if you are seeing something, routing or certain things, then you have to come back with blockage adjustment. Not to do with any memory position or anything. Your memories or IOs should be frozen by the time you have got your first CTS criteria. Why CTS criteria is basically after CTS, you will figure out that the clock cells are getting split and your clock skew is more or your insertion delay is getting longish because some logic is placed somewhere far off, which is creating your longest insertion delay or unable to balance. That means you have to move that module to somewhere. Your floor plan is all about your module placement. Getting the module placement right, both in terms of congestion, timing, and clock balance. These are three key aspects. Okay, congestion and timing are the most critical, and clock balance is the other stuff. Routability is part of the congestion. Okay, so you have to address. Okay, if your CTS, is seeing somewhere that is actually going far off and unable to balance, or your clock is actually trying to take a longest D route, you can look at, clock point of view, whether I need to create multi-point CTS or that module has to be pushed down, because of which I have to make some floor plan changes, or I have to create a move bound. Because this logic is getting spread. I don't have congestion, timing is meeting, placement timing is meeting, but post CTS timing is getting screwed up because that guy has, yeah, skew is more because that guy is sitting there, at the placement clock is ideal. Okay, and that to that extent your floor plan can change. Okay. You get the point? Okay. If you have not done a proper measure of these things, this is why correct by construction approaches, they will estimate what is your insertion delay. You have to look at structure. Otherwise, up to CTS, you will have to understand that floor plan can have a problem.
Yeah.
Yes, your floor plan is at the heart of physical design. The quality of floor plan you do will dictate how your block is routing, how much area you're able to reduce, what is the quality of timing. So floor plan is the heart of physical design. Correct.
Yes.
That's what those are all key things. When you're doing floor plan, give maximum area. Lowest utilization should be your first target. If your utilization is getting high, means it will impact timing, it will impact everything. Your most important thing, first thing, what the physical design should address, okay, getting a good floor plan. What is important? Congestion, timing, which is more important?
Congestion after
Congestion.
Condition is fine, then timing will not.
Correct. So as a PD engineer, your focus should be on routability, getting the congestion in control. If it's not routing, no matter what your timing, it won't close. Okay. But the biggest challenges are the timing ones. Okay. But irrespective, while everybody will focus on timing, your focus should be, yes, I will cover timing, but unless my routing gets solved, nothing else is important for me. My congestion should be in good shape. In addition to that, what I have to do. So, because first thing you are addressing even before you touch the stuff is you're addressing the data flow. That's not taking into. So your data flow, your floor plan, those should be the stuff. Your data flow, because data flow says, hey, I'm supposed to get the input over here and there, but you have done entirely opposite thing. Then it's a different ball game. No, so you have to take care of your architecture, front-end architecture, what is the requirement of the block, accordingly place, and in that you should address, the first thing you should address is the congestion. Okay, cover the data flow because that's your key part, how your whole stuff is going to work. Okay, so you can ask, first, my data flow should be in sync with whatever is the architecture requirement, because power domain, everything. Then next I will going to address, you should answer questions in your interview like this. What is important? My data flow, my floor plan should match the data flow. My module placement should match the data flow, more or less. That's my first criteria. If that is done, then second criteria for me is to address the condition. Okay. Then my third is operate on timing, work on it. You understand? So this should be your thought process.
Yes.
Yeah, Satish, you had some question at the time.
So in floor plan stage, actually we'll place physical cells. Can I know where exactly the physical cell information will be there? I think it will be in left. Whether it is correct or wrong. If it is wrong,
Yeah,
correct
both
me.
physical cell, yes. In the dot lib, there won't be a dot lib for physical cell.
Yes.
You have to understand there won't be any timing or power information except for decap. There will be a leakage information. Okay, but physical only cells. Okay, so you have to understand that left and these things will have that physical only information. Okay,
Okay.
and the fill, even in your dot lib when you are looking at fill, it won't have any logic stuff over there. It will tell you what is the leakage electric characteristics will be present for that. Okay.
So then it is correct. It will be in the left
Yes.
side.
See, all the cells present in left should be present in lib, present in GDS, present everywhere. But what information is present in each of that is what is different. But physical only definition will be present in left.
Okay, sir.
Left is only an abstract version.
Yes.
Left is not used by any of your actual tape out layers. It's GDS. Okay, or your stuff. Okay, because you don't want to get all the silicon layers, etc. That's why you are creating abstraction in the form of left library exchange format.
Okay.
Yeah. It'll be there in the GDS also. But left for your stuff when you are using for the PNR. Initially, you are not using GDS, no, for all the PNR, you are using left. Left, and in case of ICC, you are converting the left into Milky Way, and that's the information you are using. Frame views. Correct. In Innovus, you are directly using the left. In ICC, you are using the Milky Way. You are using a converted version.
GDS is dumping after the completion of the routing.
Yeah, that's only a wired GDS. So you are dumping using the left that whatever metal layers will be there, but that's not your full GDS. After that, you have to add all the library GDS. That is when the merging, because library will have all the below the M1 layers, no, your silicon, then your whatever NVEL transfusion, every layer has to be present. for your, so those are all layers you will have to add, then you will do DDS bunch.
Sir, one more thing. Regarding on the tap cell placement.
See, like,
ICC, because you can't have all those layers. That's when you have to go to ICV and so on and so forth, because then it will complicate. Yeah, what was the question?
Sir,
Sorry?
regarding on tap cell placement, actually, what I know means actually the tap, how will get the tap cell distance between the tap cell, means whether it will be
Okay,
given by
let me
vendors.
explain. Let me share the screen, right? Can I erase this? It's okay, right?
Yeah,
So
yes.
this is the block. And let's say your tap cell distance is 200 micron. That should be your tap. What is tap means, you should have a tap is basically a direct connection to your ground or, whatever substrate. So that
Right.
Short circuit
all the
between
latch
VDD
up
and
current can have a pass through for that. If that says 200, then your tap pitch should be 1/4 of it. That means 50 micron. Because the way you place tap is important. 50 micron is not just standard. I will tell you how. Okay. Sorry. Let me do this. Let's take this is your first circuit row. Okay, just for illustration purpose, I am just drawing 3 circuit rows on. Okay, these are your 3 circuit rows or whatever side rows. Okay, circuit rows. Okay. So now what happens is there's a if I'm placing tap cell, okay, the best way to keep minimum number of tap cell is you should have if I play you should have tap cell. Exactly below this alternate row only you have to place. I'll tell you now. Let me explain. Okay, because I will draw 2 scenarios. Okay, so that it becomes clear for you. Let's take I place the tap cell like this. Yeah, one tap cell below the other. You can place tap cell the way you want. I'll tell you the problem. But then you'll have to add more tap cell. Okay. The idea is if the requirement is that that the idea of placing tap is the requirement is that you need a tap cell for every 50 micron distance. That means, because that's the short circuit. Let's say 50 micron. I'm just giving a 50 micron. That means any cell, any standard cell which is placed here, either left or right, you should have a nearest tap cell for it to sync within 50 micron distance. That is the ask of your tap requirement. Okay, your latch up requirement. Within 50 micron from that particular cell, you need basically a hole for you to actually connect to the substrate so that my latch up issue will not exist. Okay.
Sir,
Now,
sir, how to decide that we need 50 micron?
how to decide we need 50 micron? Now that rule comes from your technology file.
Yeah, that is the main thing I need information.
The technology will describe, or your foundry
When does
document, no, that will give you the data to tell you what is the tap requirement for you.
yeah, it
That
is from
means
vendors.
50 micron, next within 50 micron, I need a tap. Basically, you can have a library, tapless and tap library. See, earlier we had with tap and without tap. In a tap library, every cell will have a tap. That means there will be a notch which will connect to the substrate. Then you don't need a tap cell in your design at all. But the problem is every standard cell has to accommodate that particular stuff. Means the standard cell will become bigger. Area of the standard cell will be high. That means overall consumption will become problematic for you. So mostly all the designs today are tapless because they found that tap library is waste. It is every standard cell has, means what is the point? Okay, if 50 byte is the requirement, then in this particular scenario, if I'm placing a standard cell over here, 50 micron here, worst case, which is the cell sitting at the middle is the one which is actually farthest from each other. That means this particular pitch has to be 100. Do we understand? In this particular case, because then only if you are placing any cell over here, either left side or right side, the maximum is 50. Because if this cell is closer to this, you have less than 50 at the left that is available, still just the left. In this case, you need more number of tap cells because every row you have to place at 100. Now look at this scenario, because you will eliminate almost 50% of the tap cell. Because here, either at the top, I am placing a cell over here. Okay. There, let's say 50 micron over here, but this guy distance is 150 micron. In this case, this has to be 100. Here I can space it in a single row 200 micron.
Because here one down.
Because in between I have another one where if I'm placing something over here, now this cross distance should be becomes 100 micron for me. It is okay. You understood, right? This is the reason why it is placed in this particular fashion.
Got it.
Same 4 cells only, it will cover 4 columns. There are only 2 columns.
Yeah, if I have to cover over here, right? So I have to add 9 cell and then one more 3. You look at, I need 9 cell to cover. Here I have used only 5. In reality, it's 50%.
Yeah.
If you want to expand for the full stuff. So with 50%, you can cover the rule of your tap exam. So this is not required. Okay. Now this is your tap cell placement. What is end cap? End cap has 2 functions. One is end cap means it is decoupling. There is also a capacitance effect too. It will decouple, the cross talk between the cell. You'll add at the boundary of this particular block. And similarly, you can add at the memories or anything, in case you want to have. So boundaries of this particular stuff is to actually minimize the crosstalk between the block sitting wire next to whatever is coming internally. One of the aspects of end cap. Other end cap cell will have internal tap or will have actually continuity. So these are all stuff that is there. To decouple the external noise to the internal of the block. Because you are closing internally, but this wire will get coupling noise effect if you don't add end cap. It will, other than the tap issue, other than the buffering issue, these are all things. So end cap is a special cell which will take care of 2-3 types of requirement. You understand? So physical
Yes.
cells are of type tap cell, end cap cell,
Filler cells.
filler cell, right? And
Space.
we'll talk about the spare cell is not a
Die cells. I hate it.
Tylo is also standard cell. Okay. So spare cells are of type, physical only cells are of type.
T-caps.
Exactly. Okay. End cap,
Pick up T cap,
fill,
cap.
tap, fill also how many types fill will be there?
At the time of end, we
Metal
can
fill, base fill.
I'm only talking about base fill. Base fill also has many sizes. You should enable all the sizes of base fill. Because if you have, there will be only one single width base. If you are adding, that means your netlist will have so many, your
Multiple
netlist
width,
size will be too big. So you should
multiple width
have,
will be
there
there.
are some filler cells which are almost like 50 site width, site row width. Okay, then you will have minimum number of filler cells. So you need to actually enable all the sizes of filler cells so that your netlist size will be less. And your whole GDS, you have to optimize your data also. So fill, you have to use it accordingly. So post fill, right? Pre-fill, in fills, there are two things, pre-fill and post fill. The tab cell, end cap are all pre-fill. That means before you do your placement, you have to add all the pre-fills. It has the priority. Post fill is after you have done routing everything, then you are going to patch.
In the cells.
Right? Post fill will have different variety of fillers. Pre-fill won't have that. Okay, pre-fill you will have tab cell, end cap cell. Okay, these things. Post fill will have decap and other filler cells. Then the third part of that is issuable filler cell. That is called gate array. This is also post fill, right? Basically, the point is it's a special cell which can be issued. That fill, it will act as a filler, but you can internally convert into, because just by changing the route, you can convert. There's an equivalent. Okay, because some standard cell logic like NAND gate, wired NAND gate, they have been constructed without altering the physical nature. NVL is there, but just with the wiring, with the metal changes, that fill as can be is created like to create a NAND gate, AND gate.
So it is a
In
spare
the
cell.
past, we
Master,
have used
exactly.
array cells. Huh?
It is also called as spare cell.
No, spare cells are different. Don't mix spare cells and this one. These are issuable filler cell.
Yeah.
You understand that? Issuable filler cell is something that fill cell will be there, but those are, you should not add issuable filler cell for every fill. That's not a recommended thing.
But
When you
can
are doing
they?
filler, post fill, you have to follow some rules. I'll tell you what the rules are. The rules are, this is a good thumb rule. You should try and use one decap for every 4 fills. 4 fillers and 1 decap. This should be the equation, or 3 fill and 1 decap, like that. So that you will spread the decaps everywhere. Okay. Decaps, when you are adding, it is helping you actually improve your IR, dynamic IR. But at the same time, it is adding leakage current to your design. And at the same time, it is adding your substrate capacitance, because it's adding capacitance also, right? So that means, power consumption is an important problem, but decaps are good. So you'll have to add it to the right quantity. 1 in every 4 cells is a good decap combination. Similarly, you can add issuable filler cell, like 50% can be issuable filler cell. 1 of every 2 filler cell you can add ECO. Because ECO again has a lot of problems, right? It will add connectivity, then all your metal layers, no, it will start troubling. Okay, because ECO is a special cell where internal wiring, everything will come. It has other aspects. So think that issuable filler cell is also another option. Okay, available. Now, spare cells are your standard cells only. Okay, standard cells, which you will have to name them as spare cells. I'll create a spare group where let's say I create a spare group of 1. In that spare group, I'll add one not cell. Every spare group, you should at least have one inverter. So that any logic can be constructed. And minimum basic gates, AND gate. Okay, with and inverter, you can create NOR, you can create NAND, you can do whatever it is. So one NAND gate and one not gate. And then you can have some NOR, you can have some 3-4 types. We'll talk about spare cell placement. Okay, but spare cells are nothing but your standard cells, but those inputs and outputs are not connected. That's all. They are left floating. Okay, so how you handle each one is a separate thing. ECOable cell, only metal ECOable is possible, but you'll have to first switch that to whatever is the type of, because each cell for that particular ECOable cell, if you have made a ECO filler, so the cell will have the name ECO fill. In that ECO fill, those cells will have mapped to some standard logic, standard drive logic possible, because ECOable cell will have a lesser drive than any of your standard cells. You cannot have like 4x mux. That may not be possible with that ECOable cell. So the ECOable cell, you will have to ask for a special map. So they will tell you what this cell, if you have used the, let's say, big ECO cell, that cell may have different possible swap to any other standard cell possible. Because you will have to swap that, then only do your metal changes. Because once you swap that, because the difference between that and that particular metal changes, there is a standard cell, standard ECO cell, which is mapped with this particular ECO pillar, where the base layers between the standard ECO cell and this base layer of ECO fill are same, but the metal are different, because only the metal you are routed. You understand? Okay, the base layers are same between that particular ECO cell and map ECO library. So you will have, are you understanding this? I'll give you example.
Both are same.
Name, both are different. Yes. Okay, let me share what I am saying. Okay, look at this. Here is an Excel sheet. There will be ECO fill 1. Okay, similar to this, you can have like this. You look at over here. ECO fill 1, 2, 3, 4, 5, 6. This size may be different. Now ECO fill 1 as mapped. Okay, you want to create AND cell means and ECO E and this will be the, it will all have like ECO. This is all metal ECO. The map is E and 1 or E and 2 like that. It may have. Okay, or E not 2. So it will be mapped to something like this. Only whichever map to this what you want a NOT gate, then you will get a 2x NOT gate which is mapped to this ECO fill 1.
So these you are.
You want 1x NOT means which ECO I can swap, that's when it is like that. NOR and so some whatever is mapped. So this map table will be provided to you.
That map. Map file will be there.
No, the map file is different, but this particular stuff will come from the foundry. It's a separate thing. Map file is different. Map file, what you are actually understanding about that map file is different. That is a GDS map file, which will tell you what M1. M1 layer actually means that it is
Layer
L23 or layer 134. So
It
like
is
that, this is
really
map
plus.
layer. This is the GDS map, GDS layer map. This is what you are using in your
GDS.
for your ICC.
So it is
For your ICC to
PLU
what
plus file,
exactly is the foundry map? This stuff is what comes in your map file. But here it is like ECO. This is like a what foundry will give you additional documentation. There you will have to get this. Which all cells can I swap with this? Only these cells between this and this, the base layer will be the same. The metal layer will be different for this because the AND construction would have happened. This is where you can do metal ECO. If you are using this and this, the metal layer will change. Then you may get some metal short which you can fix. But base issue is not with that. Okay, base layer frozen means base freeze and metal ECO you can do. You have to understand this. Okay, because this is a limitation. That means, this guy, if I want just add one cell, I don't have anything over here because this guy is not mapped like that. I don't have. Okay, 2 input AND gate. I need 3 input AND gate. That's not mapped to filler. This ECO fill one and only is sitting close by. I don't have 3 input AND gate. Then what will I do? How do I manage? Either logically we have to construct, no? How to create, 3 input means 2 input over here, add one more like that. Or the other idea is, as I was saying, now this one is all part of force fill, right? This is all part of force fill. You have no control where it is going to get placed. Yes. This tool will place automatically wherever it finds space because in your dense region. Okay. But when you know by design, I have some very critical paths which is not tested, which is not done properly. There could be timing challenges, etc., etc. How should I deal with it? That means upfront, you are assuming that there are challenges that is going to happen. Then the important that you plan for ECOs at a very early stage. That means ECO design you have to create, physical design for ECO. In this case only comes the concept of space. Now pre-fill, when you are done this like this, okay, all your end caps are placed. Next you place your, this one. Then you will add your end-well fill, right? End-well everywhere tapped when you have done, and then this is done. Pre-fill is done. Next I create spare cell. That's now spare cell. I create spare cell group 1, group 2. You can create as many groups. And spare cell group 1. Now spare cell, once you have created one spare cell group, let us say which has small AND cell, AND gate, NOT gate, so that you can construct anything with that. They will write the logic to do that. Now that one you'll have to place it in a matrix fashion. That means every 100 micron I need a spare cell, or every 200 micron I need a spare cell. So you can create a region of 200 micron. Okay, so that you place, this is the spare cell group. You are creating a region for that spare cell group and you are allowing the spare cell to play. You create small regions at a distance of 200 micron everywhere. And tag this to spare cell. So all the spare cells will sit over here. It's not supposed to move away from that. That means whatever logic, and you have to fix this. It is a bound, but it's a fixed bound. This bound should not be moved. You understand? So you can create the spare cell like this, regions like this, and allow the spare cells in the matrix so that whatever cell, if I have, at least I know maximum distance I have to travel for any connect is 100 micron. I should be okay. You understand? If I have got a logic over here, 100 micron, or if this is closer to this, 100 micron like that, like this. Okay.
Yes, it will not.
Sir, what is
It will not.
sir, what is
Other cell.
It will impact in certain way because you are actually trying to block this area for space.
Yeah.
But that is the requirement, right?
Yeah.
Why basically because because most of the issue will come in the most complex. See, wherever is your critical path. Critical path means where the timing is very critical, right? In those paths only, mostly you will have lot of bugs or timing issue.
Sure, that is
When the timing path is very critical, that means the cells are going to sit very close. The density is going to be close to 100% in that area.
So that is exclusive bound, right?
Huh?
Exclusive bound.
Exclusive. No,
Only-
you don't have to make it exclusive. Other cells can be sit there, but the point over there is, but standard cell should sit there. Your spare cell should sit there. Don't make it exclusive. But, but this is a bound, hard bound for the
Yes.
spare cells. For spare cells, you have to create a hard bound, but not make it exclusive. You don't have to make it exclusive. If other cells have space to sit there, it can sit without impacting condition. Don't create an exclusive bound, create a hard bound, but allow if the cells are, because you won't be able to estimate exactly what is the bound. Not required to make it exclusive.
Sir, what about fiducial cell, sir?
Huh?
Fiducial cell.
Judicial cell. No?
Fiducial cell.
Judicial cell. No? I have not heard of it, man. What is it? Fiducial, physical only cells. It's nothing but physical. It's a physical only cell, man. They are using the other name. Sorry. That's all. Fiducial cell and physical only cell are the same.
Okay, got it.
Fiducial marking therein. Okay.
Okay, it is like I think even I saw this fiducial cell in PCB designing. Means it is a reference cell, reference point. I think means for
Shallow
like
trench layer isolator. I'll look at this and tell you, man. Okay. Not aware this, but we'll look at that. I just need to read a little architecture. Anyway, that's okay. Typical. So any other questions in the floor plan? So when do you first say your floor plan is good? Is when you look at your color code, your modules, and find that modules are sitting in the manner that your data flow diagram is expected, and they are not getting split. Okay, because once it's split, then again post ETS it could be a problem. Right? So you have to ensure that these are the things.
We're placing the modules that means based on frequency we will place. But
You are not creating fly lines for modules. No?
means based macro placements.
Yeah.
Macro placements, we are based on fly lines, we will place that one.
No, first thing I told you, macro placement should not be based on fly lines.
Based on that.
Macro, yes, it should be based on your data flow diagram, or you can look at your module hierarchy and accordingly which macro is supposed to be in that hierarchy. That's where the fly line connectivity between the macros, I told you, right? If keeping or hope, or if that is actually, if there is, you can still enable the fly line after doing module based, hierarchy based, placement, and you still see that macros at the bottom are connecting to something at the top, that which is what will be shown by fly line. You can understand why that is happening. You need to ask the designer why this guy is actually talking, can we split, or because this guy is supposed to sit there as per the module. But if he says that no, they need to be closer only. Okay, because there are 2-3 scenarios I will tell you. Be very clear. Because the fly line connectivity may not have happened just because of the RTL. Because RTL has given, but DFT would have screwed up.
Maybe.
I will tell you how. Because when they are adding MBIST, no, they are combining this memory and that memory. So the BIST connectivity is what creating your fly line logic. Tool won't understand.
Yeah.
So if you are allowing the tool, this word screwed up, then that is why designer is sitting over here. You have to say, no, this module is supposed to be here. You have to create a separate MBIST group for this. You understand why macro we are not giving control to the automated is because tool is won't understand these things. We have to say DFT is screwing up. You go and divide this. Okay, or it could be that this macro and that one logic as is required because there is a control signal which is coming, like some enable is controlling this and that overall. Okay, then should I create, the designer would have provided for the timing map. Okay, that means there should be proper register buffer so that the timing path will meet. You understand this enable that one because the common cell may sit somewhere else, which has to create a high fan out tree like that. Okay, so it's always important you don't go and this guy is connected over here, I'll go and sit. No, this is what engineers do. No, they make this common mistake because they have been always taught in the training. Look at the fly line, place them closer. ऐसी बात नहीं होती. That's why I told you golden rule. Data flow diagram. If data flow diagram is not available, hierarchical browser. Use that, ask, sit with the designer, because that is the only window you have to actually interact. You cannot do after close to tape out. I want to talk to the designer. My timing is not working.
Floor plan only, we need to spend.
Yes, yes. Floor plan is at the heart of your design.
The rest of things automatically will
Correct.
make it happen.
Rest you don't have much control. The tool is doing what it has to do. Hello, Priya. Office lab, intruder. Training lab. You understand? Okay. See, there are hundreds of things. If I sit and talk on phone, and I can talk. Okay. Now, what I have told you is a very tip of the iceberg. Now, let us say there are power domains. Okay, let me give you a brief introduction to those things, right? So now in a floor plan, one thing what you have to be careful. So these are also typical questions which can come. You should know at least conceptual. So where should your isolation cell sit? Where should it sit?
We have multiple region that the place means different block modules will be there. Modules which one will always on. Based upon that, we will use some cells. If that particular block is or module need to some on and off conditions at that moment one cells. Based on this, we can use those isolation cells.
No, this is not the way to answer the question. And I will tell you.
It
First,
should be placed in
understand.
always on.
Always on.
Yes.
What?
Isolation cell has to be placed in always on area.
Isolation cell should be placed in always on domain. Yes, correct. But where? Isolation cells you will always place close to the port. Correct? Isolation cell should not have any driver after the isolation cell. Isolation cell should be the last cells connecting to the port.
This way.
Will you place, first of all, isolation multi-voltage is a different, multi-voltage means there are two different voltages. That means voltage levels are different. In voltage levels are different, for that you don't need isolation. Only for a domain where voltages have to be shut off. Okay, where there is a shut off domain, on domain, off domain, then only isolation comes in the picture. And isolation is required for the logic which is going out from the
Always on, shut down.
off domain to the on domain.
Like interface between like
Pass
the
the
block which are
information.
shut down and
Huh?
always on.
Pass the information clearly. Or suddenly off condition is there. Isolation cell will give the power to that particular off domain.
Isolation cell won't give the power to the off domain. Isolation cell will always be placed in the block which has a off domain, but connected to always on cells. Understand? It has to be, this is a they will confuse you like this. Should the isolation cell be placed in the off domain or on domain logic? It will always be in the shut off domain block only. It won't be in the always on domain block. It won't be there. But it has to be connected to always on domain power.
Sitting
The
in-
power, it should sit inside
sitting
the
in off domain and-
inside the block which is supposed to be shut off. Because even if it's shut off, okay, this guy should be on, and it should only be the nets which are going away from off domain to on domain. That means the output pins of the off domain only needs isolation, not the input pins of your off domain. It does not need isolation. Why? Why the
Enab-
input pins of off domain, does not need isolation? You tell me.
Means at the output only we will get the data. If suddenly power of that domain, the data will pass through the on domain.
At least
That
that
output
data is valid.
Yeah.
The data
But-
which is coming into the
Because-
stuff, it does not
Oh.
care, no, this is shut off. It's not required. So you don't need to use isolation for both input and output. Only for the output pins of your off domain, you need isolation.
Enable signal should be wants to connect it to in always on.
Ah,
Isolation.
now
Enable
let's
signal.
talk about, that's the second factor. In the
Yes.
off domain also, there will be some cells. This is a off domain. This is supposed to be a block which can be shut off. Even if it's shut off, certain logic should work. For example, if you have a clock route going inside, okay, which is a pass through, or feed throughs are there, which is going from one on domain to another. They are all supposed to connect to the always on domain voltage levels only, no? So those things have to connect to the always on feed through. This is my feed through. This is not supposed to be shut off. Isolation should be connected to feed through. Okay, if you have a registered, isolation can be of 3-4 types. And isolation, or isolation, or registered isolation. What are these things? What is and isolation? What is or isolation?
And
Yeah, for logic and cell is an isolation cell, so that one of its inputs will be always tied to 0. So any change that happens to the other pin, the output will be always kept at 0. So that any signal propagates from this off domain will not enter into the on domain. I mean, it will not reflect into on domain. Similarly, for AND logic, our cells will be the isolation cells.
means under isolation means only power from both will come.
Let's look at and as a digital thing, right? And means if both inputs are one, then only output is one, right? But this was supposed to be a signal, right? That means what should be the other one? It should always be in and it should be connected to tie high. So that this guy, if it is 0, output will go as 0. If this guy is 1, output will go as 1. But if you are using like this, and this guy is shut off, then it goes to Z pin. So you have to understand that's the logic thing. And isolation means output should be following the input. That means the other one should be connected to 1 or something. Or means, that's supposed to be connected to 0 so that it has a pass through. Then what happens, how you are actually going to control in isolation is like that. Memory means it should store the previous bit.
Yes, retention
Okay.
cells.
So previous data so that it registers and that register should be connected so that that registered data is always maintained for that as an output for that. You understood? So this one, the designer will decide. Don't worry for now. Okay, because it's too early for you to understand. It's okay. You can have like this. This is a general concept. It can have a registered or it can have any of that. So in a shut-off domain, what are the special cells that you are going to use? isolation you are going to use. Tie high, tie low, whether it is you will use in all kinds of domain, wherever tie high, tie low is. What are the special cells that you are going to use in a shut-off domain?
Shut-off means power meters.
Power gators, yes, that is called empty CMOS or power gators. What are those?
Power meters.
Power switch.
What is a power gate cell?
Power gate means it will switch on the power supply to that particular position.
So I'll construct. See, basically, if this block, so I'll remove this, everything new. I'll explain because there are so many options. Okay. Let's talk about one block. Okay. So this is supposed to be shut down, right? So this can be shut down. Means, this particular power connectivity, whatever is coming. Okay. Because today you are having flip chip, right? Today, many of the designs, that means all the power bumps are on top of these things. So you can control this shut off from the package also. Let's say these bumps which are sitting on top are not supplying power to this. Okay, and these power routes are cut outside. Then if you are not supplying power to this, then this block won't get power. Okay, that is one way of controlling. You can control all the way from system level to chip level. Now we are talking about.
Upon means it will connect to power also.
Yeah, the power comes only.
Power.
That power you can shut off. Assume imaginatively you are shutting off that power. The bumps which are coming are not supplying current to this. Then you won't get current.
Yeah, we won't.
You don't need power gators then, right? You can control, regulate from there to anywhere. Imagine. But in this case, for your stuff, assume that power is coming from the top. Okay, but you are actually logically controlling such that you are shutting off this block while keeping all the without touching any power pumps. Okay, then that power bump will connect to your standard metal 12 or whatever your top level metal layer is M12. It is going to connect to M12. So your M12 power is like this. Then this mesh is your always on power mesh because this is connecting to your
Connecting to M12.
M12. This is a M12 which is connecting to your bump. Whatever is connecting to your bump is your always on, which you are not actually supposed to touch. This is going okay. Now you will have to create a mesh, strap mesh, separate mesh, but you are not supposed to connect this one. You are not supposed to add wires to this M12. This connection. This is your shut off domain.
Yes.
Power domain. So here what you will do is you will add a power gator. Okay, power gator means that guy, this power gator has three signals. One is called sleep signal. Okay, so this guy will have like always on power. Power gator will have always on power connectivity, but it will have an output power like this. It will have power port. This guy, whether it gets whether the current is flowing through this or not will depend on this switch logic. Sleep or switch. There are three signals. We will talk about that.
Input, output, sleep signal.
Correct. So, and based on which it will decide whether this has to come. So this is the net. This is the mesh to which this mesh is supposed to get connected. So you'll have to add as many because this drive of each power gator is very small. It may be 10 microamp or 10 milliamp or something like that. If it's supposed to have like 1 amp, this particular block is consuming 1 amp. That means if each of your power gator is supposed to supply only 1 milliamp, how many power gators are required? 1000.
Sir, 1000.
10 power minus 3, 10 power minus 6, no? So you need at least 1000 minimum. Good thing about that is you should at least add 50% margin to that, okay? Go 2000, let us say, whatever, because IR drop also, no, this guy is supposed to get support means you'll have a lot of problem, okay? So you'll add this particular stuff, okay? Now we'll talk about rush current analysis, etc. Just I'll give you 2-3 concepts over here. So this power getter again has to be connected in a mesh fashion. That means it should be in a matrix everywhere. Okay, it should be there.
So every wire having one power getter.
Power getters will be placed in every like 10 micron, just like I spoke about spare cell, no? Every 10 micron, you can add one power getter, place it like that. And this mesh should be connected to that. This guy should go and connect. This particular output mesh should connect. So when you are actually adding this, you cannot add one over here, one over here. It should be aligned so that this route is continuous, right? This power route. So when you are placing floor plan, you have to take care that these are properly aligned on the vertical and horizontal direction. Otherwise, what you will have to manually connect. No, those are all wrong thing. You are not. I'm talking about, when you are doing floor plan, this should be aligned properly. Power getter. Similarly, isolation, I want to tell you so many things. Okay. So power getter vertically, horizontally, it should align so that this particular, whenever I am drawing a mesh, I can directly hook like that. And you should not switch like this. Orientation should not be switched. If vertical side, the orientation should be same because then the pins will be exactly aligned. This power pin, which is supposed to connect to the top level, this should exactly be underneath this particular top mesh. M12. That's when easily you can drop a wire. Otherwise, what you will do, you'll add another extra route causing congestion. So floor planning with this particular stuff is also important. All this you have to do. The tool will do something, but you will have to manually check whether these are happened properly or not. You understood? Okay. So input power is this one, output power is this. Then what happens is when I give a signal that, okay, you sleep or it's shut off, then it goes that it turns up these things, switches it off. The problem is once you have switched it off and suddenly you are turning on everything. That means all the logic are at a time getting power. That's what is called rush current. And that is going to destroy. Because only one part of the logic is supposed to, you have estimated that your IR is going to happen. 15% of the cell at any time is going to be on. But when you're turning off and turning on at a time, that is what is called turning on, power on. Okay, scenario, and this is very important scenario, you have to sequence it. That is when the sleep should be in a daisy chain manner like this. You are going to connect things like this. But the problem is when you're doing like this daisy chain, the power getters which are over here are going to get after a long time.
Okay.
Okay, so this will actually take a huge delay before the whole system turns on, which is also not desirable. So you use a mix of these things. So only one particular part, let's say 10 of these gets connected in a daisy chain. Okay, but you will have a mesh come daisy chain fashion. Parallel, you will have to use a combination. Okay, so that about 10% at least gets turned on at a time and then rest gets sequenced.
Then first one we can give some extra time. Then after that.
This is what is daisy chain. It's going to do like that. Okay. So you think about like this. Floor plan, you have to do it in proper manner. Mesh, and this has to be orientation properly done so that the routes can sit, and it has to think like that when you are actually talking about that. Isolation will come in a shut off. You understand? In a multi-voltage and shut off also, you can have, in that case, you will have to have level shifter plus isolation plus everything. You understood? Now, that's about. Now, where will you place your isolation cell? So this is about power gate placement. And for the always on, you're directly going to hook from the main mesh. Okay, not from, this will be connected as, this will be a VDDA. This will be VDD. Okay, and VDDA isolated is where it has to connect, but the ground, okay, will be common for both. the sides.
Ground because only power supply will be the different.
Okay. You have to
Sir,
understand that.
sir, what is the difference between power gating and power switch?
Both are same.
Both are same, sir. Okay.
Okay.
Isolation cell will place at the output of this.
Yes, so you will place, again, when you are placing isolation, see, isolation are also pixels. You will have to align it properly. You don't place at every pin and leave it like that. It may not be possible because there will be 10 pins. At every pin, you may, because isolation cell are big.
Only data.
So maybe one on top of each other, close to that, and then connected. So that when the isolation always on wire will come in a single shot and connect. But this particular net which is connecting will be short. And you cannot have long because then the wiring has to be very short. So you'll have to place it in accordance with that. Isolation cell 4444 like this, you can line up, connect it properly, align it properly in terms of floor plan, so that you are doing minimum disturbance.
Isolation cells not for every pins, only whichever the data is important for that, but
For every output pin, need isolation.
even power pins also.
Not power pins. No, power pins are not there.
Means only data pins, data and signal pins. Means clock and signal pins.
Yes, any output clocks and this one, that's where you need that. Okay. Where, I mean, scan pins, even the scan out, right? They need not be isolated.
That's right.
Why? Basically, that you'll have to discuss with the DFT.
Whether
Okay.
that is
But then you'll have to add special rules to make that check also, because when you are actually doing checker, right? You know, VCLT checker, because every output this is there, but this is a scan pin, you know, because when the scan is happening, you're not actually really worried whether it's shut off or not, because you are testing for manufacturing. And then you will allow everything to pass one at a time, module, this one, that one, and all. You can isolate and check. Okay. The scan outs need not be isolated, but this, based on the design architecture, we have to decide.
But
Okay.
it has to mention in the checker time, checking time.
Yeah, if you are adding that, then those special rules, because standard rules will be like outputs, whether you want to measure or not, you'll have to give all that. Okay. Now, level shifter, whether you will add level shifter comes in the picture, whether you will add level shifter for a lower voltage or a higher voltage domain. Where will you add a level shifter?
Higher to lower.
Low to high.
Let me ask the question, right?
There are two types of
There are
level
two things
shifter.
you are confused. Both the stuff are.
High level and low level shifters.
High to low, low to high.
These are two blocks. Let's say this is 1 volt. This is 1.2 volt, right? You have actually signals going from this domain to here. Okay. And the other way also. Okay. There are two questions. Whether you will add level shifter in this block or you will add level shifter in this block.
This one.
The first block.
One
You
point.
can have in the first block.
You'll add in the level shifter in the 1 volt block or 1.2 volt block. You answer. You'll add level shifter in the 1 volt block.
The 1 volt block.
Low to high.
Okay. I will tell you, you should add the level shifter in the 1.2 volt block. Okay. And I will tell you how and why. Because if you have to add 1 volt block. That means you have to boost to 1.2 volt. That means there should be another 1.2 volt supply over here. No, here you can actually reduce the voltage from 1.2. You can derive 1 volt.
Yes.
Here you will have to increase the voltage. That means you have to add voltage boosters, current boosters.
Yes.
Okay, these are things that are actually required. Now, how and why? Okay, whether these inputs are required or outputs are required is the second part. Let's say you are adding voltage level shifters here in 1 point higher voltage domain. In a higher voltage domain, now you want to actually add, this is a 1 volt. This higher voltage domain won't understand. So definitely you need a level shifter 1.2 level shifter, which will convert this 1 volt to 1.2.
Okay.
Correct?
Ah.
You need this. Whether you need level shifter for 1.2 volt to 1 volt. That is the question.
1.21.
No. What is voltage? This is the stuff. No. Even if it is 1 volt, anyway, there's a clamp. See, there are different stuff. What there is a something called clamp cell. No? What is a clamp cell? Have you used clamps in your blocks? If you have used your low voltage
Yeah.
clamp is there.
Diodes.
Okay, that is
Diodes.
there. Yes. So the key part
The current goes
over
to
here
saturated.
is okay. Now level shifter, whether it's required or not, because as long as it is more than noise margin is what? For low, anything less than, let's say for 1 volt, 0.8 volt, sorry, 0.2 volt or less, 0.2 volt or less will be considered as a zero, logical zero.
Zero.
Anything
That is
0.8
zero.
and above will be considered as logical high, like this,
Yeah.
right? There will be a drop anyway, like this in the signal. So, but in this case, what will happen is 1.2 volt, it can still read. It will be more than this. So as long as it reaches 1 volt,
Yeah.
it can understand. The
Yes.
problem is noise margin over here will be too high. You'll have to add a clamp cell and then, do that. So this will still work if you don't have level shifter over here, but it can impact your noise margin. Okay, so if it is like 0.9 to 1, you may not require for the output pins from here. Inputs is required in this case because this is a higher voltage domain. Because this guy won't understand 1 volt, no, 1.2 volt, because it will anyway hit 1 volt. So you add a clamp cell and do that. Whether it is required or not is based on the voltage difference between these two.
So if that is 2 voltage means then we need to add.
You need to add. Okay.
If not,
So otherwise you can add a clamp cell, to keep it at level of 1 volt. Clamp will clamp it at 1 volt and leave it for you to understand.
okay. At here, we can.
Here you need level shifter,
But at this place.
clamp is good enough. Okay.
Clamp or level shifter.
Yeah, level shifter. Okay. Or you can supply the voltage directly also. Okay, depending if the voltage difference is small. Okay. So these three things you have to choose an option. Understood?
Yes.
But anyhow, here clamps will be well, right?
There are no clamps now. This guy is getting a low voltage, right? So once you are adding a clamp up to 1 volt,
If we are not adding clamps or anything here,
then you will have to add.
we have already clamps here, right?
You have to add clamp.
Huh.
You have to add clamp here. Then only you will be able to
Either one
clamp that
clamp
one.
should become. Why we can't use here? Here only we can boost up the signal and can pass.
You cannot boosting this stuff. You'll have to add 1.2 volt supply. How you will add?
Leakage
Okay.
because of there will be a
Level shifter also
leakage.
need to power supply.
Yeah. Okay, then you will have to add a current circuit and then you will have to convert a volt 1.2 volt. How you will supply, right? That signal, right? So this guy is supposed to have that voltage.
Also, another reason is there will be a leakage.
So I think from floor plan point of view, we have covered reasonable aspect. Any other questions? If I ask, I'll ask, right? You know, I don't want to ask everything. Because this focus is more from interview point of view, right? You know, I've never interviewed you guys like that. I used to, no, so whatever. So it's very difficult for people to pass, but but we are allowed to break. When you are actually passing this information, it is very important. Okay, now let's talk about few things. How would you qualify a floor plan?
When when we match the data flow diagram, everything is perfectly module placement.
There should be reasonable good match between the data flow diagram and your floor plan, right? Module placement should match roughly and congestion should be good and timing should be meetable. Then my floor plan is good. All the power domain stuff should be taken care.
But congestion means we can't estimate rate congestion or timing and the.
No, that is you cannot do just a macro placement where floor plan is done, right? Floor plan is a loop until CTS. Until routing also you will look at whether it is routable and come before you freeze there are iterations.
Iteration.
There are iterations. But the point is when you have floor plan, you are saying this is good means this is what it is. Okay. So module placement. Then similarly, say some things. What are the things? What are the exits?
All input output IO pins ports has to be placed and fixed, and macros has to be fixed. Then
See, input pins, when you're
and
actually having
clusters.
M level, pins have to be placed in proper layers. You cannot place horizontal pins on vertical layers. Proper track. It should be track. You should ensure that the pins are actually connecting to the right ones or the externally also. Okay. Whether if the block is abutted to this, then those pins and this pins are to be placed exactly matching. That will come on the top. Ensure that that is done. In that case, you don't have much option to move, right? So, and what
Base layer
things,
DHCP,
your utilization of your blocks.
base layer
Yes, the
DHCP has to
blockages
be
should be properly placed, right? So, wherever there are like a buffer only blockage, too many macro intensive means, you have to ensure that all the around the macros, where the buffer only blockage, use the right things, right? Halo blockage, buffer only blockage, partial blockage, all these things have to be properly used. So that, you understand, right? When will you use buffer only blockage and when you will use partial blockage?
Partial blockage means we have congestion, we can make it.
in between the channel
Partial
spacing.
blockage will allow all the cells.
Yes.
In between the
Okay,
channel,
but it will add more routes in that when you have channels, right? Inside channels, you should not use partial blockage. Because then you'll add more routes than what you actually estimated. But in some cases, it can reduce the route also because if it is muxing and all. So this is where the option comes in. You'll have to experiment. Okay, you'll have to say that if the data, if the output pins of these two things are going to combine into a mux and come out as a single net, that means the routes that are coming out are less or for me. So if there are mux like that, then we will use. Okay, so you will try and actually avoid inside deep channels in macros and all. You will add buffer only blockage only for buffering, but certain cases where the timing is tight and you have to do, then we will add partial blockages to try and actually make sure to spacing. And for memories, what is the utilization you are supposed to use? How you will compute the block size? For memories, you should not take more than 10% extra area.
10% extra area.
For standard cell, like you are using 60% utilization. For memory, you can use 80 to 90% utilization. You should not use 100%.
Okay.
You understood, right? Some area, extra area is required, but it's not like standard cell, you will give 50%. So about 80% or 90% utilization for memories for standard.
30%.
Yeah, 10-15% is maximum what you should give for memories. Extra area for buffering or channel routing or things like that. If your overall area is like that, this is how you should have to compute. For memory, if there is 1 micron, then I'll compute 1.2 micron. How I'll come out with an area for the block? Let's say there is 1 micron, 1 mm square of memory. 2 mm square of standard cell logic. What is the area of the block required? If somebody were to ask this question. So 2 mm square of standard cell logic, 2 mm square divided by, let's say my initial utilization is 60%.
At the stage of power plant.
Yes. And you have to be very clear. Huh? If you have too many feed throughs, that is, you have like 10,000 feed throughs. External feed throughs routes are dominating, means your utilization, because those pins, those cells, those buffers are going to get added. They are going to block a lot of top level nodes. Your utilization will come down. You cannot use 60% utilization if there are so many feet. 60% feed through means I may recommend 50%. That and all you will have to try and play in reality and try and do. But depending on the feed throughs, my initial utilization of 60% is reasonable.
Sir,
So
what is
60% divided 2 mm square divided by 0.6, which means 3.3. That is the standard cell area required. Similarly, for memory, 1 mm square divided by 80% utilization, let me say 0.8 is 1.25. My total area requirement is 3.3 plus 1.25, 4.5 mm square. That's my area requirement. You cannot say 1 mm square plus 2 mm square, 3 mm square divided by 0.6, 5 mm square. Not like that. You have to compute. And it's a power gated block, like low power. Then you don't have your power gating is only coming inside the logic. Then for that power gator extra area for that logic, that's a separate, that's the computation you have to do. You understood? So compute like this. Standard cells, 60%. Memories or hard macros, 80 to 90%. 90% is what they would expect. You'll have to play with.
Of 180 to 90% we need to.
Yeah, the block will be used. Only 10% extra margin for some routing will be available for. That's all. So if it is 1 mm square of, if it's a macro dominant design, let's say if it is 4 mm square of macro area, 2 mm square of logic area. This is, I have dealt with blocks like, or even 1 mm square. 5 mm square is the total area divided by 0.68 mm square. So if it's a macro dominated, then 80% utilization is a reasonable. If it's not macro dominated, 10% is a reasonable. To start with. So 4 mm square divided by 0.8, because it's a macro dominated. So I will get about 5 mm square. 1 mm square divided by 0.6, 1.5 mm square. So 6.5 mm square is my block area required. This is your initial estimation. This is how you do. You understood that?
Macro dominant. If not that one. So
0.9. 4 by 0.9. If I have like, let's say 6 mm square of logic, so 8 mm square of logic, okay. 4 by 0.9 starting utilization. Then you'll have to justify. I need more area means you'll have to justify why, whether you have done the right floor plan. You may have given big spaces. If it's a rectilinear block, I'm not able to use this much. It's causing my problem. Things like that. You understood?
Sir, coming
Okay.
to feed through, can I know what are
Yes.
the sir, coming to feed through, what are the different types of feed throughs is there, sir?
Different
feed
types
through.
of feed through, sir. No, there
Yes.
is feed through means, it is like logic coming in, going out, that's all. Okay. But there could be a repeater logic, repeater thing, where you are adding flops inside for that because the path is not meeting timing. So repeater cells are added means there is a flop which is used to replicate the same logic sequential. Feed through means it is like input output shorted. That's what it means.
Yes. Actually, in one of my blog, there was around 206, 2,600 feed throughs was there.
Ah.
So I got it in some of questions. I told about feed through, but they asked about how many repeaters was there. So on the time, I'm not able to exactly
How
tell
many
that.
repeaters means, what is the size of your block? See, if your size of your block is, let us say 3 mm square,
Actually my block
width is
is
3 mm. Huh?
my block is a channel block. It is in 7,000 micron to 8,000 micron.
So now you are coming to 7,000 to 8,000. And
Yeah.
let's say you are operating at 2 gigahertz. Okay.
Yeah.
2 gigahertz means you can assume that one buffer, every 200 micron, one buffer, 200 micron, every buffer you are adding. Then 200 micron means 50 picosecond delay.
Okay.
For every 200 micron, you have 50 picosecond delay. You have to meet 2 gigahertz means, you have only 500 picosecond available to you. How many buffers can you add? 50 picosecond is one buffer delay means. Not only 10 buffers. Okay. So 10 buffers, 10 into 200 is 2000 micron is what you can drive. That means you need repeater. If you have 8 mm square means you need at least 4 repeaters. 4 flops in between to meet that frequency, no? 4 repeaters per net multiplied by 2,600. So that becomes 10,000 repeaters. 10,400 repeaters. Simple. These are all mathematical calculations you have to do.
Okay.
You don't do. You don't do engineering. You are tool runners.
Yeah.
Seriously, sir. People are means previously people are running that handling, tool handling, but now everything is flow dependent.
Yes, bad flow. Product flows. Today also it is the same thing. You have to use your brain. You have locked it. Okay. So when you get caught, when you answer like this is when they will ask, have you done? Okay, this guy has not done. They will judge whether you have done or not. You have to say this. Okay, but don't bluff. If you have not really computed, not really thought of that question, I don't know, sir, I got it. That is a fair question to ask. You say, no, sir, this is done, this guy is bluffing. Somebody's project he copied. This happens. Isn't it? I don't know why Nupur has not joined this session. She could have joined. Banaja might not have informed. I think useful information, no? What lot of things. Okay. Any other question you want to ask? And when you are dealing with feed throughs, first thing you have to look at is their fly lines of feed throughs. It should not be zigzag. The pin, try and make it as straight as possible. Input and output in straight line, that is the shortest distance. Sometimes, it will be like from left side to bottom.
Yes.
It could be like that also. Then you will have to really make it align left pin to left pin, bottom pin, top pin to right. Last, it should be like that. If it's zigzag, no, there will be a lot of crisscrossing and you will get condition.
Actually,
Don't try
actually,
crisscrossing.
in my block, it was from top to bottom. And if it is there any crisscross, so I used to inform to top level the placement of.
Correct. They will align. Then
They
after
will go
that,
to align
in
that feed
wherever
throughs.
you have feed throughs, no, there you have to add partial blockage.
Yeah.
Okay, that path you try to add partial blockage because if you are trying to overutilize, it is going to consume routes also, then you won't be able to do it 200.
Yes.
You understood? That's the where you have to look at overall utilization.
Sir, just 2 minutes. Try to transfer.
So you look at these things in this conceptual mind. Okay. Lingeshwar Yajna, any questions you have? And
No,
yeah.
sir.
For you, everything is new, right?
Yes, sir.
You'll understand. Yeah,
We
yeah.
listened all the
Yeah, no
discussion.
problem.
Okay, sir.
The other part is now you have to, before you exit your floor plan, your floor plan DRC should be clean. So enable fill and run actually your DRC checker. You should not have any shots, etc. Your DRC should be power DRC, power shot should not be there. Those things should be
Base layer
clean,
DRC,
right?
base layer DRC should be clean.
Yes, okay, filler base DRC should be clean, okay? Before you run DRC check, you had post fills. You post fill that and run a DRC check. Then it will give you base DRC clean. Or it will tell you all the issues. Macro to macro, it's not working, If DRCs are there, no point in proceeding beyond that because it will further screw up all your placement. Okay? Do good floor plan, do it proper neatly, get it base DRC clean. If somebody is hurrying you, I need feedback on my netlist. I've released, I have to give. You have not worked on your floor plan, but they need a database. They need a feedback. You run a parallel stuff. Just fire a run, but your job for closure should be to get the floor plan clean. Just fire a run for them. One dummy run, one license is available, fire. Let it go. You want feedback, you take this timing. You put a disclaimer. This is a just dummy run. I have not done anything over here because I am working on floor plan cleanup. Okay, but this is what, and every time you can add that in the next iteration, whatever limited cleanup you have done, you add that new floor plan, allow that dummy runs to keep going. Correct?
Yeah.
As I
Okay.
in one of my blog, I saw that in base layer DRCC, like because of the tab cell, it's not present because the row orientation is changed in a netlist. It should be in R0 and R90 in layer orientation, but it was reverse. So I'm getting around 5 lakh DRCs in base layer.
Yeah. See, in the lower node technologies, when you are running, it should be like color code properly should be there. The M1 metal layer, macro color code, and this one should align. Okay. Alternate means you can reverse the color and still make it work. But the macro color codes means, red and yellow in double
Tracking,
patterning, triple
triple track.
patterning layers, they have to line up. Okay, properly. The track should be proper. Okay, you have to take care of grid positioning properly. Okay, you have to make a macro to macro position proper. There are all set of rules already given. Follow those guidelines, foundry guidelines when you are doing floor plan.
Like yeah,
The
in
spacing
macros,
between the macro block edge to your circuit row, what it should be, what should be the height. Okay, all these rules, at least right now I'll talk rules because if I talk, then we will just get stuck here. Okay, so then all your check library, check timing. Okay, yeah, and check design, all this should be clean before you exit your floor plan. You understood? You have to check. And also check
Yes.
if you are low power, everything done. Check for formal verification. Go for one CLP check so that you have not screwed up anything. Right? So do a CLP check also. And if that violation is there, okay, we will fix it later also. You can proceed, but you have to check all that. Okay, you have to check. Yeah. Both are not same. It is power enabled logic equivalence. That means, the power domain crossing checks, etc. also will happen. Yes. Conformal low power. That is similarly equal for this one is for synopsis is
Liberty.
MB checks. Huh?
MB check. It will also be
FV formal verification.
Oh, listening and
FV are same.
If you
For
Check
FV
MV
is
design.
formal LEC, it's all formal verification.
Check MV design.
CLP is low power enhanced because all the low power cross domain crossing is taken care of. Okay, that's about floor plan. You have to check all that, make it neat. You understood?
Yes, yes, sir. It was very useful.
Shall we go to placement? You want a lunch break?
Yeah. Hope everyone starts to get hungry by this time.
2.5 hours we consumed just for discussing this.
That was
But I
wonderful,
hope you
sir.
got some information.
Really, really yes. It was very informative.
Okay.
Yeah.
Just enable the, I mean, whenever we are having this discussion, no, or recording is there, at least somebody can share, I think. Recording enabled.
Sir, Miss Manaja is recording it.
Banaja is recording. Okay,
Yeah.
so I'll ask Banaja to share the recording with Nupur
With
also.
yeah, to all the participants, if you can kindly.
Yeah.
Yes.
Okay, then we will break for lunch for some time. Okay,
Fine.
again we will assemble in 30 minutes time.
As you wish.
13:05. Huh?
Yeah, please, you please decide. Yeah. I mean, how it's
Satish
possible.
and everyone, you need more time?
No need, sir.
You need 2 o'clock. Okay, we'll
Sir,
meet at 2.
Yeah.
Yeah, we'll meet at 2. No problem.
Sure, fine.
But I'll have to rush through other ones, because today we have to send the proposal. I don't have much time. Okay,
Let's-
thank you.
Actually, we'll,
Bye.
sir, actually, we'll spend more time on CTS.
Yeah, but we'll touch base on all the queries. So think over in this lunch, what questions you get in placement and CTS. You have to come. Okay, you ask more questions, we'll answer. Tuck. Otherwise,
Yes.
because I have touched only 1% of floor plan. You imagine how many things are there. If I were to investigate, so many things are there. But this itself is good for you to at least give some clarity about. Okay, thanks.
Thanks, sir. Thank you.